This video is all about the cone, just like an ice cream cone, and we'll discuss lateral and surface areas as well as volume. So again, the cone is just like what it comes to mind when you say the word cone or ice cream cone. Specifically though, in terms of geometry, we're going to call it a geometric figure in which the base is a circle, and then the upper surface narrows to a single point. And like the pyramid, that single point is called the vertex. So if I'm looking at that picture, this point right here would be the vertex of your cone. Just like in the pyramid, the altitude or the height of the cone is going to be the perpendicular distance that exists between the vertex and the base. So in this picture right here, the red line segment represents the height of my cone. Just like in the pyramid, the slant height is going to be the distance from that vertex to any point along the edge of the base. So there's the slant height of my cone. And you could probably see the right triangle formed in there by the red line segment, the green line segment, and the blue line segment. So just like with the pyramid, if you know the height but want to find the slant height, or vice versa, you can use a little bit of Pythagorean Theorem due to the fact that that triangle is a right triangle. All right, let's talk formulas. To find the lateral area of a cone, you're either going to multiply 1/2 times the circumference of the circle times the slant height, or if you go to the formula sheet, on the formula sheet, lateral area is defined as pi times the radius times the slant height. These formulas are two different ways of expressing the same exact idea, so you can use whichever one you prefer or feel more comfortable working with. The surface area of a cone, just like the pyramid, is going to be the sum of its lateral area and the area of its one single base. And then just like the pyramid, the volume for a cone is 1/3 of the product of the area of the base times the height. Or if you want to, you could say 1/3 times pi times the radius squared times the height. And if you think about it, that pi r squared is really that area of the base. So again, it's two different ways to name the same exact formula. You should pick and work with whichever one you're most comfortable with. All right, let's get into some practice. Number 1 says a circle has an area of 25 pi square units. When a point is extended 12 inches straight down from the center of that circle, we get a right circular cone. They want us to find both the lateral and the surface areas of the cone. And then once we do that, find its volume. Since we don't have a picture of this cone, the very first thing that I'm going to do is draw one. So it talks about a circle. I'm always going to start by drawing that circular base. It says when a point is extended 12 inches straight down from the center of that circle. So there's my center, there's my point that's 12 inches straight down. We form the cone. So there's our cone that's formed. They want us to, again, find the lateral and surface area of the cone. So for lateral area, I'm going to use the formula pi times r times L, but you can use circumference of the base times the height. So let's go find the radius of our circle. They don't tell us anything about the circle except that its area is 25 square inches. So I want to know the radius. I know the formula that they used in order to determine that area was area equals pi times r squared. So when I plug in 25 pi for the area, I end up with 25 pi equals pi times r squared, which means the radius squared is equal to 25, and the radius can either be plus or minus 5. Since we never talk about length in negative units, we're going to use 5 for the radius of our circle. So now that we know its radius, I'm going to go up here and label that in my picture, and I should have what I need to go ahead and determine the lateral area. Slant height. If I go look at my picture, I know the radius is 5, I know the height is 12, the slant height is going to be that purple segment in my cone. And unfortunately, at this point, I don't know the slant height. But I do know that the height and the radius form a right angle, So there's that there's that right triangle again. So I'm going to go ahead and use the Pythagorean theorem. If you happen to know your Pythagorean triples, you may already know what the hypotenuse of that is. But if you don't, just go ahead and plug it into the Pythagorean theorem, and we'll find our slant height. So we find the length of the hypotenuse to be either plus or minus 13. We want the positive length. So now I'm going to go plug into my calculator, and I want to multiply the 5 times the 13. Notice that in the directions, it just simply says find the lateral and surface areas. It doesn't say rounded to the nearest inch or rounded to the nearest tenth of an inch. Since it doesn't specify any kind of rounding, I'm going to leave my answer as an exact value in terms of pi. So my lateral area here is 65 square inches. Now the surface area, on the other hand, is made up of that lateral area, which we just found, plus the area of the square base. And this is going to be relatively simple to find because we know the lateral area. We know the area of the base. They tell us in the beginning that that circle has an area of 25 pi square units. So when I go ahead and combine the 65 pi plus the 25 pi, we find that the total surface area is 90 pi, either square inches or inches squared, however you're comfortable with expressing that. All right, now that we've found both the lateral and surface areas, let's go ahead and find the volume. The formula for finding the volume equals 1/3 times the area of the base times the height of our cone. So luckily, we already know the area of the base. They told us the area of the base is 25 pi. And we already know the height of our cone. The height of our cone is 12. And make sure you use the height and not the slant height. Like the area, they don't specify any kind of rounding. So I'm going to leave my volume in exact volume in terms of pi. So I'm going to go ahead and grab my calculator, and into my calculator I'm going to enter 1/3 times 25 times 12. And when I punch all three of those numbers into the calculator, it tells me 100. And I haven't yet done anything with the pi, so it's going to be along for the ride. So the volume here, 100 pi in either cubic inches or inches cubed. All right, moving on to the next one. It says a cone has a radius of 9 centimeters and a volume of 675 pi cubic centimeters. They want us to work backwards now and determine the height of the cone. So like the first question, there's no picture, and whenever there's no picture, the very first thing that I'm going to do is draw a diagram. So for my cone here, I'm going to start by drawing that circular base. I'll put the vertex up here, put these guys in here. All right, now I'm going to go label the information they've given to me in the problem. So the radius is 9 centimeters. I'll go label that in my diagram. The volume is 675 pi cubic centimeters. I really don't have a way to label that in the picture. And now I'm to the part where it's asking me to determine the height of the cone. All right, so I really don't have anything else in the picture. The height is what I'm looking for. I'm going to call that h. All right, so what do I know about this guy? I know that he has a volume of 675 pi cubic centimeters. So I'm going to go ahead and start out by writing down my volume formula. Volume equals 1/3 times the area of the base times the height of the cone. And now I'm going to go substitute into the formula everything that I know. So I know the volume is 675 pi. So let me go ahead and plug that in. I don't know the area of the base, but I can find it, because if I go over here and look at my picture, I see that circular base with a radius of 9, and I can definitely find the area of a circle. So the area of my circle is 81 pi times the height, which is what I'm trying to find. All right, I'm noticing pi is a factor on the left side of my equation and pi is a factor on the right side of my equation. So I can either divide both sides by pi, or you might think just cross off out a pi from each side. So I get 675 on the left side. And now I'm going to go ahead and I'm going to multiply the 1/3 times the 81. When I multiply the 1/3 times the 81, my calculator tells me 27 times h. So to undo multiplying by 27, I'm going to divide both sides by 27. So on the right side now, I'm left with an h, which is what I wanted. On the left side, I've got 675 divided by 27, which gives me an answer of 25. So the question asks for me to find the height of the cone. The height of the cone is going to be equal to 9 centimeters. All right, so there is the cone. Why don't you go ahead and in your own words on the next page, make sure you take some time to think about and reflect and summarize the key ideas and important understandings, and then see if you can apply what you have learned in order to solve the questions on the next page.